Good day, students. We are here again in our pre-calculus class, and we will be talking about angles and circles. Now, what is an angle in standard position? An angle in standard position, if its initial side is the positive x-axis and the side common endpoint is the origin. Measure the angle is taken to be positive if the initial side has to be turned counterclockwise to cover the measure and negative if clockwise. 1 revolution, 1 rev, the measure when the initial side takes exactly 1 complete counterclockwise to coincide with the terminal side. 1 degree is equivalent to 1 over 360th of a revolution. And 1 radian or 1 rad, the measure if the angle intercepts in the unit circle an arc of length 1. And you have to take note of this conversion. 1 revolution is equivalent to 360 degrees, and that is equivalent to 2 pi radian. And what is coterminal angles? Angles which in standard position share the same terminal side even if they might have different measures. Thus, these are angles whose measures differ by an integer multiple of a revolution. And what is quadrantal angle? An angle whose terminal side lies on one of the coordinate axes. Thus, these are angles whose measures are multiples of a quarter of a revolution. The length S of an arc of a circle of radius r, subtending a central angle of measure, radians, is given by S is equal to r times the central angle, where the S is the length of an arc of a circle and the r is the radius. And you have to take note that the angle's measure has to be in radians for this formula to be valid. And another formula here. We have the area A of the sector of a circle of radius r, subtending a central angle of measure of the angle is in radians, is given by A is equal to 1/2 times the square of the radius times the given central angle. An angle is formed by rotating a ray about its endpoint. An angle is said to be positive if the ray rotates in a counterclockwise direction or kanang bali na direction sa clock. And the angle is negative if it rotates in a clockwise direction, like sa direction sa pagtuyok sa orasan. So these are the given example. So if this is an angle, here we have the angle is drawn in the Cartesian plane, and the initial side is at the fourth, this below the fourth quadrant, and the terminal side where the other ray of the angle is at the first quadrant. So, and here, the first picture, this is counterclockwise, and here is the clockwise. So you have to take note that it is said to be positive if the ray rotates in a counterclockwise direction, and the angle is negative if it rotates in a clockwise direction. So here, the first example is in counterclockwise direction, and the second example is the clockwise direction. Okay, example 1. Shown here are angles in standard position of measure. We have 3/4 revolution. So the Cartesian plane is divided into 4 equal parts, and we have to sketch the angles, that is 3/4 revolution. So we will start here at the x-axis, and this is positive 3/4 revolution. So we have 1, 2, and 3. And you have to put arrow in sketching the angle in standard position. Number 2 is negative 1/6 revolution. Since that is negative, so our direction is clockwise. So from the x-axis, we have to start there, then clockwise direction. Since the given revolution is 1/6, so we have negative 1/6, so we have to divide the Cartesian plane into 12 equal parts. So that means kada quadrant we have to divide them by 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 11. 7, 8, 9, and 10, 11, 12. So there are 12 equal parts here, and negative 1/6 is at 2/12 part. So here, because 2/12, if we are going to make that or change that in simplest form, that is negative 1/6. So that is in clockwise direction. And the third is 2 revolutions. Since that is positive, our movement is counterclockwise. So we have to start here. 1. From the x-axis, you have to go 1 circle to the x-axis again, and another 1. Since 2 revolutions, that means we have to form 2 revolutions. Okay, we will go to example 2. The measures in degree of the angles in example 1 are calculated as follows. Number 1, 3/4 revolution. And we will convert that in degrees. Since 1 revolution is equivalent to 360 degrees, that will be used in changing or converting revolution to degrees. So 3/4 revolution times 360 degrees over 1 revolution, and we have to cancel out those unit revolution. So our remaining unit is degrees. So we have 3 times 360, or 3 times 360 equals 1,180 divided by 4 equals 270 degrees. Therefore, 3/4 revolution is 270 degrees. Next is negative 1/6 revolution times 360 degrees over 1 revolution. So cancel out revolution unit, and 1 times 300, that is negative 1 times 360 is negative 360 divided by 6, that is negative 60 degrees. Because if you are going to divide negative and positive, they have opposite signs, so the quotient is negative. So that is why negative 1/6 revolution is equivalent to negative 60 degrees. And number 3, we have 2 revolutions times 360 degrees over 1 revolution, canceled out the revolution unit, and the remaining is degrees. So we have 2 times 360 is 720. Divided by 1 is still 720 degrees. So you have to remember always the constant conversion unit that we are going to use if we are going to convert revolution to degrees. You have to multiply the given revolution to 360 degrees over 1 revolution. Example 3. Sketch the given angle in standard position with the given measure. So the given measure is in degrees, that is negative 120 degrees. In solution that is given is we have to take note that we have to convert first the degrees to revolutions so that it will be easy for you to sketch the angle. So we have negative 120 degrees times the constant conversion, that is 1 revolution over 360 degrees. So whatever unit nga inyong pangitaon mo na ibutang sa numerator, since we will convert the degree to revolution. So the 1 revolution should be at the numerator and the degree should be at the denominator, and you have to cancel out the degree unit. So we have already revolution as the unit that we are going to use. So negative 120 degrees times 1 is over 360 degrees. So negative 120 times 1 is negative 120 over 360. And that is a big fraction. So we have to simplify that. Divide both numerator and denominator by 120. So 120 divided by 120 is 1, and 360 divided by 120 is 3. So the simplest form is negative 1/3 revolution. Thus, the required angle is shown below. Since the Cartesian plane has 4 equal parts already, so we have to divide this into 12 equal parts again. And asa nga part ng negative 1/3. And that is negative, so our movement is clockwise. So we have 1, 2, 3. 3 equal parts here. 3, 3, 3. And since now negative 1/3 is equivalent to 4 over 12. Because 4 divided by 4 is 1, and 12 divided by 4 is 3. So 4 over 12 and 1/3 is the same, and that's negative. So our movement also is clockwise. So 1, 2, 3, and 4. Don't forget to put arrow kung asa mo nag-stop sa inyong gi-sketch nga angle. Okay, next is 990 degrees. Before we convert measures, we note that 990 degrees is equivalent to 2 times 360 degrees, or duha ka 360 degrees plus 270 degrees, indicating that the angle is coterminal with an angle measure 270 degrees. Thus, to sketch the angle, we need only sketch 270 degrees angle, and then from the currently obtained terminal side, sketch curved arrows representing 2 complete counterclockwise turns. Since 990 is 2 times 360, so we have 2 complete revolutions. So our movement is counterclockwise since that is positive. And then, as we know that 270 degrees can be 3/4 revolution if we are going to convert that to revolution. So we will move 2 revolutions. 1, 2, and then taman here, second 3/4. Thus, the required angle is shown as, or is as shown below. So this is the required angle if the given degree is 990 degrees. 1 radian is the measure of a central angle. That's a symbol for the central angle. We have a circle, and then naibadis to nga. That intercepts an arc equal in length to the radius r of the circle. So algebraically, this means that the given central angle is equivalent to ds over dr, where that symbol is, or the central angle is measured in radians. Now we have the conversions between degrees and radians. To convert degrees to radians, multiply degrees by pi radian over 180 degrees. And to convert radians to degrees, multiply radians by 180 degrees over pi radian. So to apply these two conversion rules, use the basic relationship. Pi radian is equivalent to 180 degrees. So 180 degrees is equivalent to pi radians. Example 4. Sketch the angle in standard position with a given measure. We have 7 pi over 4 radians. So the given is in radian. Then solution. Note that 7 pi over 4 radian times 1 revolution is equivalent to 2 pi radian, because 1 revolution is 360 degrees and the bus conversion nato gayna is 180 degrees is equal to pi radian. So if that is 360 degrees and that is 1 revolution is equivalent also to 2 pi radian. And 7 pi times 1 is 7 pi, and 2 pi radian times 4 is 8 pi. So since we have already canceled out the radian unit, so the remaining unit is revolution, and we can cancel out that pi at the numerator and the pi at the denominator. So 7 na lang o 8 ang nabilin. So we have 7/8 revolution. Thus, the required angle is as shown. So we will divide the Cartesian plane into 8 equal parts. So 1, 2, 3, 4, 5, 6, 7, 8. So our last our graph or our angle should be at the 7th part. So dirataman siya and put arrow. Now, what is an arc length? For circle radius r, a central angle intercepts an arc of length s is given by s is equal to radius times the given central angle. So the length of the circular arc where the angle is measured in radians. And note that if r is equal to 1, then s is equal to the given central angle, and the radian measure of the given central angle equals the arc length. We will go to this theorem. The length of an arc of a circle. The length s of an arc of a circle of radius r, subtending a central angle of measure in radian, is given by s is equal to r times the given central angle. We will proceed to example 5. Number 1. The length of an arc of a circle of radius 16 meters that subtends the central angle of measure 3 pi over 4 radian is, again, what's the formula? S is equal to the given radius times what is the given angle in radian. So as we know that the radius in the problem is 16 meters, so we have 16 times 3 pi over 4 is equal to 12 pi meters, because 16 times 3 is 48 pi over 4, and that is 12. Or to be easy, we have to cancel out 16 and 4, or 16 divided by 4 is 4, times 3 is 12, times pi is 12 pi meters. Number 2, the measure in degrees of the angle subtended by an arc of length 20 pi inches in a circle of radius 5 feet is, we have 20 pi inches over 5 feet radian times 180 degrees over pi radian. That's the constant conversion. Is equal to 20 pi inches over 5 feet times 12 inches, because we will convert those feet into inches. So 5 times 12. We have to multiply it with 180 degrees over pi radian, because it's a constant conversion. So we'll cancel out the radian unit. So we have 20 pi times 180 because we also canceled out the inches. So 20 pi times 180 divided by 5 times 12 is 60, and that is 60 degrees. Now we will go to the theorem. Area bisector of a circle. The area A of the sector of a circle of radius r subtending a central angle of measure in radian is given by A is equal to 1/2 times the given central angle in radian times the square of the radius. We will go to example 6. The area sector of a circle of radius 16 meters that subtends the central angle of measure 3 pi over 4 radian is, okay, as we know that the given formula is A is equal to 1/2. 1/2 is constant there, times the given central angle in radian times the square of the radius. So we have 1/2 times 3 pi over 4 times 16 squared. So 1/2 times 3 pi over 4 times 256, because 16 squared is 256, is equal to 96 pi square meters, because 1 times 3 is 3 times 16 divided by 8. So the result is 96 pi square meter. Okay, we will go to the historical gem. The sexagesimal number system. Ever wondered why 360 is the number of slices chosen to define degree? Diba? The whole circle is 360 degrees. It comes from a number system used by many ancient cultures, such as the Babylonians, that counts by 60. So those, as we know that those Babylonians are mathematicians. And do you know that those people there in ancient times, they are mathematicians. That is why Daniel and his friends studied there. So this is called sexagesimal number system. It is the same system that underlies the way nowadays measure time. That is, 1 hour is composed of 60 minutes, 1 minute is composed of 60 seconds. Some say it might be the combination of number systems based at 6 and at 10. That is the usual decimal number system. Some say it is due to astronomical consideration. Most likely, it is due to the convenience that 60 is divisible by a lot more possible numbers, allowing more subdivisions for the first set of numbers in the system. So for our integration of faith and learning, like triangles, there are 3 sides and angles. There are also 3 simple sides to Christian faith. We have faith, hope, and love. These 3, and the greatest of these is love, that is found in 1 Corinthians 13, verse 13. So we have to love God above all in every angle of our life. That's all for today. I hope you learn something about angles and circles.